My name is Timo Meckler. I'm a product manager and architect at SmartDeploy AI.
And my name is Charles Aditloy. I'm an MLOps platform engineer at SmartDeploy AI.
SmartDeploy AI is a software platform that we've developed that really allows anyone, both individuals and teams, to quickly and easily collaborate and run AI and ML workflows at scale.
So in our talk today, we're going to be talking about our journey from Cassandra to Scylla, the things that we did to be able to run Scylla successfully on Kubernetes. And now we integrated this with our data pipeline, our AI ML pipeline for streaming and ingesting data. And now we're able to realize up to 10x performance gain for doing all these things with ScyllaDB on Kubernetes.
We're just going to talk a little bit about ourselves. So I primarily lead our product development. I also work on architecture on a platform. Prior to doing that, I spent quite a number of years as both an analyst and a strategist working in the energy commodity space, building models and working with traders, and then ended up joining Charles to do some big data consulting before launching SmartDeploy AI. Charles here right next to me has got, well, at this point I would say probably well over 15 years of experience building large-scale distributed systems for quite a number of different applications. He's got a ton of consulting experience and is familiar with quite a number of platforms. A little bit about our company, SmartDeploy AI. So we're a Texas-based company, and we develop software platforms and frameworks for running and deploying AI and ML workflows at scale. So our primary focus really is about increasing the productivity and the agility of development teams, increasing collaboration among teams that working on data science. We think data science is a team sport, not an individual sport. So really driving collaboration, breaking down organizational barriers. And then last, and this one's really important, being able to create shareable and reusable AI and ML workflow pipeline components. We think at SmartDeploy AI that AI is right now more like a puzzle. It's pretty hard, but we think it should be more like Legos. You should be able to take pieces and build things up and easily create what you want and be able to run AI at scale. Now, having said that, let's get to the core of our talk and talk a little bit about IoT. So laying the foundation, so what's an IoT device? I think maybe a better question today is what isn't an IoT device? The number of connected devices has really grown over the last number of years. I just looked up some statistics before this talk. I found some numbers from Gartner in 2018 that predicting up to 25 billion with a B connected devices by 2021. I'm sure that's now out of date and it's even greater. But the key is that there are going to be far more connected devices than there are going to be people, and it'll just continue to grow. But all these devices are generating data, and we really think of that data as really as generating events. So all the IoT devices are event sources, generating time-bounded events that are then consumed by an event consumer on the other side. So you might have a phone or a camera or a car generating events, and that's then consumed by maybe a model, maybe a BI platform, some sort of other analytics on the other end. And now those events can, as you guys surely know, can take different shape and form. You can have very, very evenly spaced events, maybe something pinging a server every 30 seconds. There's something that comes very bursty upon a certain type of trigger event, or you can have events that maybe are more seasonal in nature, that ramp up in the morning and then maybe ramp down at night, or some other type of seasonality. But it's really, when you have that, it's really more than just event producers and consumers. You need a way to process those events. And for that, we make an event processing pipeline to really be able to handle this large amount of data that may come in different intervals, different seasonalities, and so forth. And this is a pretty good model to start with. You have devices producing events, you have a processing pipeline, and you have consumption. But with a large number of devices, it quickly gets more complex. What if your IoT devices are spread geographically? What if you've got devices all over the world? How do you handle the scalability of your infrastructure to manage devices all over the world? That some may come online in Asia, some may come online in the US. Basically being able to scale your infrastructure as appropriate, instead of leaving it all just on and paying a huge bill. So being able to manage scale and scaling up and down. And it's not just that, it's also that devices might be for different customers. We can't just grab all the data and lump it all together. We may have different customers. There may be security considerations. There may be the need for running multiple pipelines in parallel. So having kind of laid the foundation there, how do we at SmartDeploy AI kind of think about a generalized IoT pipeline for AI and ML. So really to us, it kind of breaks down to 4 major parts. You've got the data ingestion that needs to happen at scale. There are solutions and technologies that are well known. We work on GCP, PubSub as being one, Kafka, MQTT. Then we need to actually process that data, data flow on GCP, Spark, Apache Beam, and then finally store that process to transform data, whether that's either on cloud storage or in a database solution, Cassandra, Scylla. And finally, once we've got that data, it's the consumption downstream of that using analytics, AI, ML, or maybe just BI tools to be able to look at the data and get a better sense of what we can do with it, what features are important before going to advanced analytics. With that, I'm going to pass it on to my colleague who's going to talk about this in a little bit more detail.
Yeah, sure. Thank you, Chibo. So our goal is to build an AI ML pipeline that we can instantiate whenever we have all these data streams coming in. We want to be able to bootstrap this pipeline on the fly and things like that. So I'm going to walk you through our journey, how we came from where we were 5 years ago and where we are right now doing things with Scylla and Kubernetes. So just to reiterate, so when we started this project and this platform, we wanted to be able to create this platform, this pipeline that can ingest the data. We want to be able to simplify the whole process of taking in the data, processing the data, and syncing it to whatever data source we decided to go with. So in 2014, when we started consulting around this is the lay of the land. This was the way our landscape was. So we had all these devices bringing in data, either from dumping it on RabbitMQ, MQTT, or Kafka, and we had to bootstrap Spark nodes on Amazon or Azure or GCP. So from there, we can either do it with Spark or run Akka streams to take in this data. Then once we do that, we get our data to Cassandra, and from there, we wanted to do machine learning. We're working on anomaly detection, or we want to identify patterns in the data, in our data streaming data coming in. We needed to train the model, deploy the model. But one thing we were not able to do with this platform and the way it is as it was then was being able to run our model on the fly and get a result and be able to do our inferencing. We have to do things offline and just get the model out, then put it back and things like that. So with that, we had a little bit of downtime. So some of the pros and cons of what we were doing then was we're able to get these things working almost in real time, where we can scale up, bring in all these devices. And it worked for us because the back end is Cassandra. It's NoSQL, so we can get all these highly unstructured data in place. It's not like we're trying to push it to a SQL database. And it created a path for us to do things like ML. Even though we're doing it offline, we're processing the data offline after ingesting the data, but we're able to lay the foundation and things like that for this. But the downside was all these things were not easily scalable. We brought up, if you bring up a Cassandra cluster and you create a ring, and you want to scale it, sometimes we have downtime, sometimes it's not easy. The Cassandra JVM just takes a lot of space and a lot of memory, and the whole process was just, it was a nightmare setting it up. If we want to set up the pipeline, we have to do a lot of things. But what we really wanted to do was to be able to anytime we get a new client, we want to be able to get them onboarded, get them running right away. But with this approach, our database grew. Our database was growing a lot, and we're not able to do this right away. So we started looking at how we can scale up our system and make things a lot more efficient. So one of the things we looked at, that was in the early 2017, was moving our compute workloads to Kubernetes. So all the things that we do and running our Spark jobs and everything, we're able to just abstract all those as Docker pods and containers running on Kubernetes. So every time we sign up a new customer, we can easily just spin up a pod for their ingestion nodes. We have Akka pods that does the processing, and we're still using Cassandra. So that was the last part because the ultimate goal for us was to be able to move everything to Kubernetes, but at this stage we were not able to do that. So we had that Cassandra running separately. We bring in the data, we process it. So at this stage we're halfway there because right now we can scale our compute instance, but the thing that was still a bottleneck was the Cassandra part. So every time we have a new pipeline or want to build a new process, we can easily scale the process. The side of the process that has to do with compute because everything is running on Kubernetes at that point. So the pros and cons of that, we're able to like get, we were able to like deploy our entire workflow on Kubernetes, but like I said earlier, it wasn't really scalable. Cassandra was a bottleneck for us, so I think around that point we started, since we met the Scylla guys at the conference in Austin, Texas, and they were telling us about Scylla, and now these can do the same thing that Cassandra does, but it was still at the early stage at that point, so, but in-house, we're trying to like see how we can Dockerize Cassandra pods and move them all the way to the Kubernetes cluster. So we got started on that. We converted our Cassandra nodes to pods. And whenever we instantiate a pipeline, we create a workflow that basically creates the ingestion system, creates the compute pods, and we can do like Akka clustering for the processing. And on the Cassandra side, we can persist the data for each pipeline. So, but the downside to that was Cassandra pods were basically sucking up a lot of memory and compute. So like every time we bootstrap a new cluster and we start up the system, the Cassandra pods were taking like up to 60 to 65% of our compute resource. So we noticed that that wasn't going to work for us. So one thing that, so every time we weren't able to like basically scale up the system, we had, because ultimately what we want to be able to do is to like bootstrap all these ML pipelines from end to end. But with this approach, Cassandra was a pain point for us, and tuning the JVM and things like that was something that we were doing. So we decided to move to Scylla. And what we found out was like slow feed, don't eat. That was the rationale behind us shifting to Scylla. So we moved to ScyllaDB. And for us, the main reason that we moved to Scylla was it was a drop-in replacement for Cassandra. So all the SQL queries and all the things that we're doing with Cassandra, we can just replicate this easily on Scylla. The low memory footprint, so we work in a shared environment where you're running everything in a Kubernetes namespace for a particular customer. So everything that runs in that namespace, the memory footprint requirement for Scylla was probably like 10x reduced compared to what we had before. And it was 8 times a lot more faster. So what that means is like every time we add a new set of device, we can bootstrap a pipeline, and that pipeline will instantiate all our pods for like ingestion, the data processing, and as well as the persistent layer. So we can bring in the data, process it, and we have a data sync for each individual pipeline that we're building for our customer. So, and on top of that, everything is based on the Kubernetes YAML standard. So we can easily containerize and deploy the pods on our Kubernetes and things like that. And that made it easy for us to like do things like building the entire ML workflow pipeline, because every data coming in, we can now like inference against it, store the results in real time in a ScyllaDB, and all the things that we're trying to like push out of the Kubernetes cluster, we can easily like use a message queue to push it out from there. So this is our cloud-native ML pipeline architecture. On the top side, you have the pipeline, which is basically all the steps that we normally go through. And below it, you have the persistence. So every stage of the pipeline can persist their output as an artifact that feeds into the next stage. So if I bring in an event, I can process it, get a result at the ingestion stage, save all the data output artifact, and feed in that as an input to the processing stage, then go to the inferencing stage and things like that. So to do this, we rely heavily on a project called Kubeflow that basically allows us to like build a DSL that represents data processing pipeline. And lately, we've been doing things around ScyllaDB operator that allows us to efficiently run Scylla on Kubernetes. I think Yanis from Arito has been working on this, so shout out to him. We've been using this a lot. And that basically allows us to like deploy our entire platform on Kubernetes, and we can shift and lift the entire infrastructure and run it on-prem, run it on JKE, or run it on Azure or Amazon. So it's all cloud native. So just to go into a little bit more details about our pipeline. So we have a DSL that basically describes the input events coming to the pipeline. we stitch each stage of the pipeline. So each stage is like a Docker container that creates a component. We have a specs for the input and output, and we stitch everything together through the Kubeflow DSL that connects everything together. At the same time, while we're instantiating the input pipeline, we're creating the persistent store as well with ScyllaDB operators. So every time we want to build a new pipeline or want to run a new experiment for a set of input streams, we can actually instantiate this on the fly on Kubernetes. So I'm going to pass it back to Timo to show you guys some of the use cases we've worked on for our clients.
Thanks, Charles. I thought I'd take a few minutes just to talk about some interesting use cases that we've actually used the technology for. So to start, the first use case actually involved capturing video streams from remote construction sites, locations, and then being able to use an AI and ML to be able to detect objects in those streams. Workers doing work, construction equipment, other things that's happening in those video streams, and then be able to notify someone, a construction owner, in near real time of those events taking place. So basically be able to generate a trigger notification and also being able to generate statistics on a daily or weekly basis of what was happening in terms of progress at the site to give them sort of a sense of how progress was going, maybe a more accurate sense of estimating completion date. So the pipeline for this look basically like that. So we start with ingesting our video streams, our still frames, then go ahead and process those, feed those into a model for training to be able to detect the relevant objects in the video streams. And then once we've got a model, we will deploy that model and actually do the inferencing and the prediction. And once we do the prediction, we capture all this interesting data, the number of people, the number of, for instance, the number of cranes, when people showed up, timestamps and so forth. And it's that information that we then can use ScyllaDB to store that information in DB, and then from that create tables and finally views that can then drive BI dashboards and other sort of downstream analytics. The other use case that I want to talk about actually involves using AI to paint walls. A very interesting use case where essentially you use your phone, let's say, to upload an image, and then you're able to, it'll detect the wall in that image and allow you to apply different paint schemes to that image. So this pipeline basically takes in the image, tries to figure out what room this is an image of, whether it's a bedroom, an office, a kitchen, then identifies the walls and finally allows you to apply different color schemes to those walls. So it looks something like akin to this, where we start with the image. We start with the image, we feed it into the pipeline. We figure out first, we have a model first that tells us what room most likely this is an image of. And then we have another model, a neural network that does semantic segmentation to then detect where the wall is in the image. And then finally, we're able to apply different color schemes to that image. And so again, here, very similarly to the last examples, we can heavily leverage ScyllaDB to be able to store model metadata during this process, the metrics from the inferencing, statistics, including even the results. And we can use that data then to support us to continue to do retraining, to continue to improve the model. So this was really cool, and I just want to blow it up on a bigger slide. So on the, I guess would be left side is the original image, and then on the right side, after the AI and the post-processing, it's with different color applied to the wall. So I think this is pretty cool. This was all done with AI, not with Photoshop last night. So very, very, very cool use case. With that, I'm going to pass it back to Charles here real quick to go ahead and wrap things up for us.
Yeah, sure. Thank you. So I'm just going to go through the key areas of where Scylla has really helped us and where we are right now with Scylla. And one of the things that we've been able to do successfully as a result of embracing Scylla and using ScyllaDB is we want to be able to efficiently utilize our compute resource. So I think Dor was saying this morning that if you give an engineer a cloud, then you can watch out for your bill. It's going to grow astronomically. So our goal is to, whenever we get to our clients, is to help them build a compute resource where you're not afraid of the cost of your cloud utilization and things like that. So we can actually efficiently leverage Scylla and running it on Kubernetes to create these pipelines that you can run things from end to end. So You bootstrap the pipeline. You can run multiple pipelines in parallel. So each engineer can just run their own experiment, run their own pipeline. It's a shared resource. The common base is Kubernetes. So you just come in on demand as you need a resource and run your pipeline, get a result. And once you're done, things can go down. And over time, below it, you have Kubernetes nodes that you can scale out as needed. So as you run more pipeline, as your organization grows, you can just run more pipelines and scale up your nodes to accommodate that. And obviously, the main thing, since it's all Kubernetes, everything is cloud agnostic. So you can run the same thing on-prem, on GCP, on Amazon, and on the Azure cloud. So the other thing that we use Scylla a lot for is to store the hyperparameters. So if I'm running a pipeline, I can have different input parameters. So my training model will input hyperparameters. I can store it in ScyllaDB. I can change the values and instantiate multiple pipelines from all those input parameters and see the results. In between, we want to store the states of each component in the pipeline and the metadata associated with the pipeline. So we can also run these and we run these and store the results on ScyllaDB as well. So one of the good use cases that we've also been doing we found very interesting a lot for us on Scylla is basically being able to create materialized views. So most of these IoT devices, they emit events, and we don't want to do a lot of joins and all those things. So we capture all those events. Some of them are huge payloads. So we bring it in, we do the transformation, we just dump it on Scylla. So with the new materialized view in Scylla, we can easily just create views of these different fields, do roll-ups and aggregation, and basically query these views and present it on the dashboard. So those are the key areas that we've really been enjoying using ScyllaDB for us on our ML pipeline.